So let's recall what we did the last time when we were focusing on grouped data. And with group data, then we use this formula to find the median. So before you can even calculate the median, the information that you need here, yes, we have the age and the frequency. So remember when you are reading this, essentially what we are saying is there are two individuals that are aged between 1 and 5 years. We don't know the ages themselves, but we know that two of them are aged between 1 and 5. And then in the second row, 10 people are aged between 6 and 10. Similarly, in the third one, we have 16 people that are aged between 11 and 15, and 4 people that are aged between 16 and 20, and then 8 people that are aged between 21 and 25. Then once we have that information, then we can compile the cumulative frequency. So remember the frequency, we are adding our frequency. So the first row, it's always the top frequency, which is 2. Then to get the second row, I add the next frequency to get 12. So 2 plus 10 is 12. Then with the 12, I add the 16, and then it gives me a cumulative frequency of 28. What this cumulative frequency is saying is that in the first row, only 2 people are represented. Here in the second row, it takes into account the first and the second row. So it's saying that 12 people are represented. Then in the third row, 28 people are represented. In the fourth row, 32 people are represented. And then in the last row, then everybody has been represented. So altogether, we have 40 people whose ages have been surveyed. So if we were to then find the median using this formula over here, we need to understand what do these different letters mean in our formula. So firstly, before we can get there, we need to find the median class. So where does my median fit in terms of the frequencies? So we still use that formula to give us the position. So it's a half of n plus 1. And this year it's a half of 40 plus 1. And this is 20,5. So this here is the position. So then I go to my cumulative frequency and I say, where is this 20th,5 position? So here I'm only representing 2 positions. Here, 12 positions. So it means that my 20th position, or if we look here in the frequency column, here I have 2, here I have 10, so altogether it's 12. Then when I add this one, I'm adding 16 to the 12, and that gives me the 28. So that tells me that this here is my median class. Okay, so therefore, my median class interval is 11 to 15. Okay, so once I have that, then I'm able to calculate the median. Remember, L stands for the lower class limit of that median class, which is then 11. Okay, and the N in the formula represents the total number of observations, which is 40. Then the capital F is all the frequencies before your median class. So the cumulative frequency just directly above my median class, it happens to be 12. Okay? And then the small f is the frequency of the median interval. It's this frequency over here, which is then 16. Okay? And then C is the class width. It's basically the upper minus the lower class limits. So it's basically 15 minus 11, which is equals to 4. So once I have all of that, I can substitute these values into my formula. So then I get 11 plus, in brackets, 40 divided by 2 minus 12 all over 16 and this I'm multiplying it by 4. So therefore my median is what? So 40 divided by 2 is 20, minus 12 is 8. 8 divided by 16 is a half, times 2, times 4 I mean, so that is 2. 2 plus 11 is equals to 13. So my median age is 13. Okay, so that's what we did in our last lesson. So now I'm going to show you another way to determine the median. And this is when we use the Ogive curve. Okay, the Ogive curve, basically we are working in the first quadrant of the Cartesian plane. Okay, and then we use the information in our frequency table to calculate the points that we are going to plot on the Ogive curve. And the points that we're going to plot are essentially the upper class limits. This here is going to represent the x coordinates, and the cumulative frequencies are going to represent the y coordinates. So in the first row then we have 5 and 2. In the second row we have 10 and 12. Third we have 15 and 28. In the fourth row we have 20 and 32. And lastly we have 25 and 14. Okay, so these are the points that we are going to use to draw on our ogive. So the horizontal axis represents the upper class interval or limit. Okay, so here we can see the x values, basically we are counting in fives. Okay, so 5, 10, 15, 20, 25. And then in the y-axis, let's then perhaps count in fours. Okay, so 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. Okay, so 4, 8, 16, 20, 24, 28, 32, 36, and 40. So the vertical axis, the y-axis, basically represents the cumulative, cumulative frequency. Okay, so now it's a matter of plotting the points. So my first point is at 5 and 2. So 2 is halfway between these, the 0 value and the 4. So the point will be somewhere there. Then the next one, we are at 10 and 12. So 10 and 12 is over there. 15 and 28. So we go all the way up to 28. 20 and 32, we go up to 32. Then 25 and 40 takes us right to the top. Okay, so remember this is a curve. So when we join the points, you do it freehand. It shouldn't look like that. Okay, so it should look like a curve. So we start from the origin and then we just join the points. Okay, we just join the points. Oh, I think here maybe it shouldn't be concave. Yeah, but it should be. Let's see. 15, 28, 20, and 32. So, yeah, something like that. Okay. So now we have drawn the Ogive curve. So we can use the Ogive curve to find all the quartiles. But for now, let's look at the median quartile because we know that it's in this position here, the 20,5th position. So then you go along your y-axis up until you can get to 20,5. Okay, so obviously we are going to estimate that 20,5 lies somewhere here. Then you take your ruler and you draw a dotted line across up until you get to a point on the curve itself. Then from there, we drop down. So as we are dropping down, we are going to get to a value here. So looking at this, okay, obviously you would have drawn it properly to scale. So we can sort of see here, it's sort of like halfway. So you could get away with saying that Q2 is equals to 12,5, because remember we are estimating. So yes, the actual value is 13 from using the formula, but when we are using the Ogive curve, we can safely say it's 12,5 from just reading it there. And because you are quite close to the actual amount, then you will get the mark for it. Okay. Then let's see if we're to find the lower quartile. So the lower quartile would be a quarter times 40 plus 1, and that is then 10,25. Okay, this is the position. So again here, I would then go up my axis and try and find 10,5. So I would say 10,5 is somewhere there. Then I would go across up until I get to my point here, to my curve, and then I drop down. And that's the value of Q1. So then I can sort of guess and say, okay, it's much closer to 10 than it is to the 5. So perhaps here, this value here is 8. Okay, so then we'll say, therefore, Q1 is approximately 8. It could be that it is 9, or it could be 7,5, but you are well within the range for us to mark it correctly. And then we can do the same for Q3. So Q3 is 3 over 4 times 40 plus 1. And the position here would therefore be 30,75. Okay, so that's the position. Then I would go up along my y-axis, find 30,75, it's somewhere there. Then I would go across to my curve and say it's over there. Now I would drop down to read it. So it's pointing towards the 15. So therefore, my Q3 is approximately 15. And let's label it Q3. And that is how we use the Ogive curve to find our quartiles.